The days that breaks you are the days that makes you. Don't let yourself down. Hello everyone, myself Nigar Sultana. Welcome back to RN Digital Learnings. In our previous video, we have learned the introduction of theory of computation, which includes the definition, few terminologies, and the operations of strings. In this video, we are going to learn about the languages and its operations, like concatenation, union, clean closure, and positive closure. Today, let me begin with a new topic, that is language. In our previous video, we have learned the terminologies. In terminologies, I have explained what is language. What is language? Language is a set of strings formed from some specific alphabets. I have told you what is alphabet, what are strings, what are symbols in our last video. Now let's see what is a language. So these are the set of strings which have some specific alphabets. Like if I talk about, so among the 0 and 1, 0 is one symbol and 1 is another symbol. So this is a language. I have told you language is denoted by sigma star. Then what can be the strings of these alphabets? It can be 0. First it can be an empty string. 0, 1, 0, 0, 1, 0, 1, 1, 0, 1, etc. So these all are the set of strings which make us a language. Now there are few points which we need to understand under language. So the first point is, if a language containing an empty string, that is epsilon, it is denoted by in this way. A language containing an empty string, epsilon, is denoted by a flower bracket, epsilon, and closing flower bracket. And the next point is, if a language is an empty, that is denoted by phi symbol. If a language doesn't have any member, then it is denoted by phi symbol. Next, this phi and epsilon both are not same. Now let's see what are the operations do we perform on language. So the first operation is concatenation. Next operation is union. Third is clean closure. Last operation is positive closure. Now let me explain you one by one in detail. First, let's move on to the concatenation. In our last video, we have seen what is concatenation on strings. When we combine or when we join the two strings, we get a one new string. Similarly, we are going to concatenate two languages. Let's take L as well as M. These are the two languages. Now, how can we denote these two languages for concatenation? L dot M. This means this is a language consisting of all the strings x, y, which can be found by selecting a string of x from L and a string of y from M. How it can be denoted? L dot M x, y. That is, x will be selected from L language and y can be selected from M language. I have told you that L represents one language, set of language, and M represents some set of language. Now from this, we are going to select some X from L language and Y from M language. Now let's see. Suppose L contains 0, 0, 1, 1, 1, 0. Then M contains 1, 0, 1, 1, 0. So how can we concatenate these two languages? It can be represented as L dot M, which is equals to. Now what we have to do is to concatenate this 0 has to be concatenated with the first element of the next language. Next, this 0 has to be concatenated with the second symbol. Now let's see. So this is when I concatenate this 0 dot 1 0. So how when you concatenate, it will give you 0 1 0. So the first 1 0 1. Now when you concatenate this 0 with 1 1 0, it will give it as 1 0 1 1 0. Next, this 0 1 will be concatenated with 1 0 as well as 1 1 0. 0 1 1 0. Next, 0 1 1 1 0. Concatenate. Next, this 1 1 0 will be concatenated with 1 0 as well as 1 1 0. Let's see what it gives. 1 1 0 concatenated with 1 0, comma. Again 1 1 0 concatenated with 1 1 0. So this is a new language by concatenating L as well as M. So this is your final calculation. Now let's see another operation, union. Here also let's take two languages as L and M. This is denoted by L union M. So this is the denotation of union. So how can you define this union? It's a language consisting of X strings from L and Y strings from M. So let's see how to denote this. L union M is in L, or in the sense the union X is in M. Let's take an example. If L is containing the elements as 0, 0, 1, 1, 1, 0, M contain the string as 1, 0, 1, 1, 0. Now let's union this. L union M. Now we need to combine all the elements from the set L as well as M. Now 0, take 0, 0, 1. Next, this is 1, 1, 0. Now combine this, all this, 1, 0. Already this 1, 1, 0 is present in resultant language, so no need to repeat again. We have combined L as well as M. So we got this 0 from L language, 0, 1, then 1, 1, 0, and now when you combine this here, M with L, so 1, 0, then 1, 1, 0 is already repeated, so write once. So this is your L union M. Let's see another operation, cleany closure. Now what is cleany closure? First let's denote how it will get denoted. L star. So this is a symbol for cleany closure. So this is a unary operation. So what is unary operation? The operation which is performed only on one. It can be one operand, or it can be a one language, etc. So now here we are going to take in concatenation as well as union, we were taking two languages, L and M, in the concatenation as well as in union. Now here why we are calling this cleany closure as a unary operation? Now we are going to work only with the one language. Suppose I have told you L star represents the cleany closure, L I which is equals to L0 union L1 union L2, etc. I'll explain what all are this. So now these are nothing but this is 0 or more concatenations of L. What is this L of 0? This L of 0 is nothing but language containing 0 length, the strings having the 0 length. This is your length 1 and length 2. Suppose L is a language, it is containing 0 and 1. Then what can be the L star? L star can be, first it is length 0. So length 0 in the sense it is epsilon. Okay. Next, length 1. So what is the length 1? So length 1, from this alphabet I can take 0, 1 separately, because this is a length 0 and this is a length 1, this is another length 1. Next, again union of L2, that is length 2. Length 2 is 0, 0, 0, 1, 1, 0, 1, 1. So I can define like this, length 0. So from the 0, 1 language, what can be the strings of length 0? Nothing, empty. Next, L1. So length of 1 is, I can take it as 0 as well as 1. Then L2 represent length 2, that is 2. Now it can be like 0, 0, 0, 1, 1, 0, 1, 1. If I talk about length 3, 1, 2, 3, then again 0, 0, 1, 1, 0, 0, sorry. Next 0, 1, 0, 1, 1, 1, 1, 0, 1, etc. So these all are these. So this represents the length 0. This is the length 1. These are the length 2, length 3. Now we are going to union this and we get the L star. So this is your Kleene closure. So when we union these languages, so first is your epsilon. Next length 1, 0 and 1. Next length 2 is 0, 0, 0, 1, 1, 0, 1, 1. Then 0, 0, 0, 0, 1, 0, etc. So this is your Kleene closure. Now let's see another operation, that is positive closure. First, I would like to say what is the difference between the Kleene closure as well as the positive closure. There we were including the epsilon, but here we are going to exclude the epsilon. Let's see how to denote this. This is denoted by L plus. So this positive closure is same as L star, but the difference is there is no epsilon. So this is basically one or more concatenations of languageal. There we have studied this is your 0 or more concatenation, and this is your 1 or more concatenations. So here we are going to exclude this epsilon, that is length of 0. Now let's see how to write this. So L plus is equals to Li. So now I is L1 union L2 union L3, etc. So let's take a same example. L is equals to 0, 1. Then what is L plus now? First is L1. So don't take L not here because this is excluded in positive closure. So consider only the L1. So L1 can be 0 as well as 1. Then L2 can be 0, 0, 0, 1, 1, 0, 1, 1. So L3 can be 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, then 1, 0, 1, etc. So again I need to union this. There is no epsilon. Directly start writing from the length 1, 0, 1, 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, 0, etc. So this is your positive closure. So these all are the operations of language. In our next video, we are going to learn about the finite automata. How to represent finite automata, what is transition diagrams, how to represent all the symbols, we are going to learn. Thank you for watching this video. Do subscribe and share with your friends.